My name is Yash Rane and I'm the creator of Project Arid. Project Arid, short for Agricultural Resilience and Integrated Drought Monitoring, is a satellite mission that was devised to study soil moisture levels over a period of time in southwestern United States. The overall goal of this mission is to monitor moisture levels in the soil to help scientists understand how climate change is affecting arable land, as well as predict and recognize patterns in the soil to maintain sustainability in the future. This satellite helps answer our scientific question: how is climate change affecting the frequency of droughts and soil moisture levels in southwestern United States? This satellite helps us find out how much water is being drained from the ground during growing seasons, as well as what that entails for our food supply. This is important because southwestern United States grows a large portion of the food we eat. If the soil becomes too dry, crops will fail and water will become scarce. By tracking moisture levels within the soil, we can truly see the effects of long-term droughts and understand their patterns. This satellite is built to measure the moisture in the topsoil over the span of 12 months with a frequency of every 2 to 3 days. This allows scientists to track short-term variation as well as long-term trends through a full rotation of the seasons. This data connects to the real-world problems like global warming and can help ensure the survival of farms in the drought-prone regions. To collect the data, the satellite uses 3 main tools. The first is a radiometer, which uses L-band microwave radiation to listen for signals coming from the dirt. This technology is ideal because it can see through clouds and thick plants and penetrates only 2 to 5 inches into the soil. The second tool is a radar, which sends out its own signals to create high-resolution maps of the ground. The third and final tool is a spectrometer, which acts like a specialized camera to watch land surface temperatures and vegetation to see how plants are reacting to the heat. The satellite's design relies on several key parts working synchronously together, and they are supported by a hexagonal frame that protects internal hardware and is covered in a layer of gold insulation. As you can see right here, this insulation protects the electrical components from hazardous temperatures. To power the system, we have 2 solar panels on the left and right, which are connected to a battery that is inside the satellite, as well as to communicate with stations back on Earth and to send the data that was tracked. There's a communication satellite right here. And to make sure the sensors and the satellite stay oriented properly and remain within the orbit, this ring of thrusters right here helps maintain its altitude and position. This mission will take place in a low Earth orbit. This orbit is ideal because it allows the satellite to pass over the target region at the same point repeatedly to provide consistent data that accurately accounts for different precipitation and temperature levels. This mission will give us a much better understanding of how droughts work. Scientists and water managers can use this data to better understand the reasons behind growing drought seasons and protect our food supply. And by sharing the analysis scripts and results on sites like GitHub, the mission will openly help solve the problem of water scarcity and provide a clearer picture of how our environment is changing. Thank you.